Section 3 looks at a lot of relationships between arcs and chords. There's not any vocab in this section, but it uses a lot of theorems and properties and shows relationships between arcs and chords. So that's really our first objective, is looking at relationships of arcs and chords. And then we will even look at relationships between arcs, chords, and diameters as well. So just to get us started, okay, remembering what a chord is. Remember, a chord has both of its endpoints on the edge of a circle. So FG on here would be considered a chord, along with JH. Okay, those are both chords. And in this first example, it says, if I know that arc FG is congruent to arc HJ, so this arc congruent to this arc, then I know that the segments FG and JH are equal. So you're really going to have to pay attention to what symbol are they using. Am I talking about an arc, or am I talking about a segment? So coming down here in the embroidery hoop, I tell you that arc AB is congruent, or excuse me, segment AB is congruent to segment CD. And I tell you that arc AB is 60. I want to find arc CD. So from there to there. Well, if I know that the segments are equal, then the arcs have to be equal. So it's going to be 60 degrees. That's all they're after in example 1. Going on to example 2, it's pretty similar to example 1, just uses a little algebra now. So circle J is congruent to circle K, and they tell us that arc MN is congruent to arc PQ. Well, if that's true, then my segments have to be congruent, meaning I'm going to start with the 3x minus 7 has to equal 2x plus 1. Solve it, we're going to get x equals 8, but they want us to plug it back in and find PQ. That should be segment PQ, by the way. So you can plug it into either one. They're both equal. I'm actually going to plug it into the 2x plus 1. So 2 times 8 plus 1, that is going to get me a length of 17. And that's all there is to it for example 2.